Electronically Configurable Antennas. Graduation project by Umut Akyüz and Hüseyin Talha Çulha, supervised by Professor Cenk Toker. Our system assembles three functional layers. At the top, an Adam pull to STR injects 2.4 GHz carrier through a central SMA feed. The middle layer hosts all RF distribution and control silicon, a 1-to-4 splitter, 4 1-to-2 splitters, and 8 Macom 4-bit phase shifters. The bottom layer comprises 8 commercial monopole whips that deliver the steered beam. This architecture replaces bulky, hand-tuned Wilkinson networks with calibrated ICs, reduces bias complexity, and provides 16 phase states at 22.5-degree resolution. Electromagnetic design commenced in CST Studio. A full 3D model of the 8-element array, including the perfect electric conductor ground disk and SMA launches, was created. We swept substrate permittivity and copper thickness to confirm that coplanar waveguide impedance remains within 2% tolerance for FR4 at 1.6 mm. Parametric sweep of element radius demonstrated an optimum 40.5 mm. Mutual coupling is suppressed below -12 dB while maintaining a clean cardioided main lobe. Final simulations predict amplitude balance better than a quarter decibel and isolation exceeding 18 dB across 2.35 to 2.45 GHz. Numbers later verified in hardware too. The RF network was implemented on a 2-layer FR4 board with 180 mm in diameter. All routing resides on the top as 50 ohm coplanar waveguide with ground. The underside is an uninterrupted copper plane that doubles as the monopole reference. VFNs at 2 mm pitch confine fringing fields, while miltered or curved bands preserve electrical length. A through-hole SMA launches the feed through a coaxial via directly onto the 1-to-4 splitter. Edge-mount SMAs populate 45-degree positions around the periphery. Digital management is equally compact. A 40-pin header conveys +5, -5, 3.3 volts and 6 GPIO phase lines. The -5 volt rail is generated locally by a charge pump IC in a 3 square mm package.
Hello, my name is Hüseyin Talha Çulha and that's my part. Control firmware runs on a STM32 Nucleo board. Each phase shifter receives a 4-bit word via parallel GPU. And interrupt-driven UART codes ASCII commands and assert the lines in under 2 microseconds. The code also echoes to selected azimuth, enabling seamless synchronization with our MATLAB visualizer. A concise MATLAB script calculates the array factor and exposes a helper function for our GUI. Parameters such as element spacing, wavelength, and desired beam angle are editable on the fly for future arrays. You can see our codes on the screen. During the operation, the GUI receives the current phase code, plots the instantaneous beam direction, and display individual element states. Changes issued from the STM32 appear on screen in less than 50 milliseconds, giving intuitive feedback during live test. Finally, the complete system is evaluated. The Bluetooth transmitter feeds the array at the +7 dB. Two independent Bluetooth receivers positioned 90 degrees apart. They log received power in June radio. As the phase code is advanced, the receiver aligned with the main lobe records an 80 dB increase, while the orthogonal receivers falls by the same margin, conclusively demonstrating electronic beam steering. Thank you for listening. Goodbye.